hint will help you on number 12. Okay. So again, the only graphing I've done so far are sines and cosines. And now, when we come back on Wednesday, we're going to start right away graphing the other trig functions. And I'll show you how that works. I want to try problem 10. So you can write that down if you haven't. And I also want to utilize, there's a chart, where is it? It's just a couple pages back. I'll use it with you and we'll see how it goes. But anyways, problem 10 says y equals 2/3, right, cosine 2/3 cosine of pi over 2 minus 4x plus 1. Now, the only way that I possibly have a chance at graphing this, the only way I possibly have a chance at graphing this, is if I have learned how to graph y equals cosine of x. So I'm going to see if you can do that with me very quickly. First thing you have to know is, what's the cosine of 0? Well, there's my unit circle. Here's 0 degrees. Cosine is 1, because that's the point 1, 0. You guys with me? So the cosine is 1. The cosine of 0 is 1. What about the cosine of, say, remember cosine's x-coordinate. So by the time I get to pi over 3, which is 60 degrees, that's when I'm at a half. And by the time I get to pi over 2, which is just a little bit farther, that's when I'm at 0. The cosine function is a wave, and so is the sine function. The basic difference is that they start at different places. They start at different places. Now, when we go to graph our function here, okay, a couple things are going to be different. I mean, first of all, this 2/3 changes part of the function. It changes what is known as the amplitude. What's the amplitude? Well, that's the distance. How about I word it this way? The height of the wave from equilibrium. So it's the height of the wave from equilibrium. In other words, it's the distance from here to here. The amplitude here is 1 for the basic cosine function. It's also the distance from here to here. But my amplitude, see, because I'm going to multiply my final answer by 2/3, and that's why, for example, what's the cosine of 0? 1 times 2/3 is 2/3. So it's going to take my rave and it's going to shrink it some. But let me say one more thing. See that plus 1? From college algebra, you probably know what this does. This is what we call a vertical shift. Right? Like if I told you guys, hey, graph y equals x squared, you guys say, oh, that's a parabola. And if I said, hey, graph y equals x squared plus 1, what would you do? Shift it up 1. You wouldn't sit there and worry about what x and y equals. You just say, oh, that's a shift. Same thing here. So my basic wave function, okay, my basic wave function, which normally might go up to 2/3 and down to negative 2/3, let's say, is now going to be adjusted. It's going to be shifted up 1. So when I go to graph this thing, this function goes as high as, well, let's see. If I want to get like the maximum value, how about I say it's 5/3? And if I want to get the minimum value, how about I say it's 1/3? And let's see if that makes sense to you. Because the center line used to be at 0. Now the center line is at 1, which is 3/3. And do you see that that's the distance that I want my cosine function wave to be? Okay. And I hate to say it, guys, I'm at 10:45, so I'll have to pick it up again here on Wednesday. But maybe this is starting to help. Right? But I want to say a little bit about some of the other things in the directions. When you're doing number 10, the directions state the period, amplitude, phase shift, and vertical shift. I talked about 2 of those last time. Okay? So we talked about amplitude last time, the height of the wave. Okay? And we said that in general, for the basic cosine function, the amplitude is 1. But for the function we're dealing with, what's the amplitude going to be? Well, I said it's going to be 2/3. And I guess I want to show you why that is. Okay? So let me do a couple things here. If you guys have a graphing calculator, pull that out. And I'd like to graph 2 things. I'd first like to graph cosine of x. And then the second thing I want to graph is I want to graph this function right next to it. Okay? So let's see. On the y equals screen, I don't want that. Let me just graph cosine of x, because that's kind of like the basic function. And then under y2, I'm going to go ahead and type this whole thing in. So I have 2 divided by 3, that's 2/3, times cosine, open parentheses, notice, and it says pi over 2 minus 4x, close parentheses, plus 1. Okay? So we have 2 graphs here going on. And, oh, by the way, you might remember I mentioned this last time. If I just press enter, I might not like the graph I get, but if I press zoom, which zoom do we like to use? Well, down here, choice 7 says zoom trig for me. I'm not sure if it's going to be a 7 for you, but what it's going to graph, it's going to graph the cosine function, and then here's the other function. This is problem 10's graph. You guys see it? So we mentioned last time that there's a vertical shift of how much? 1. That's this extra little plus 1 out here. Okay? That's why the wave seems like it's not centered at 0, because you're adding 1 to all of the outputs. And the other thing we notice is that the wave is smaller, and that's because the amplitude isn't 1. The amplitude is 2/3. You guys see that? But what I haven't said today is how would you actually draw this graph without a calculator? Okay? And that is a more complicated process. Okay? But what you have to do, first of all, is you have to understand, as I alluded to last time, y equals cosine of x. Now, when the book does this, they do a nice job, I think, of this part. They say, hey, guys, I know that there are some important x's, and there's going to be some we're going to graph some x's and some y's. But see, I already know something about the basic cosine function. Okay? So I understand there are certain inputs and outputs that I understand very well. So what I'm going to do is make a little chart. And for the input and output, when I say this stuff in here, what I'm really thinking of is I'm thinking about y equals the cosine of x. Or maybe I'll say theta. You know? These inputs are my thetas, if you want. Now, what angles do we usually use when we talk about cosine. What are some of the important angles? Well, things like 0. What's the cosine of 0? Sure. Or pi over 4. That's 45 degrees, and we know that that's square root of 2 over 2. And so you'll see this kind of thing in the book where they keep going up by pi over 4 because, for example, what's the cosine of pi over 2? Yeah, that's that 90-degree mark on the unit circle, so that's 0, right? I take a look, that's 0. And so the book will go ahead, they'll say 3 pi over 4, we're at, again, radical 2 over 2, and then when we get to pi, now we're at negative 1. Right? If I kind of skip ahead, when I get to 3 pi over 2, I'll be back to 0. And when I get to 2 pi, that's the same as 0, so that's going to be 1. Okay? And the book calls this a fundamental cycle, right? This is what we might call one period. Because, again, we know that the wave is going to go down and up. Okay? So, I guess the question is, what are the inputs going to be and what are the outputs going to be? Now, the outputs are actually easier. Okay? Used to be, I had an output of 1. Well, now I'm doing a couple things to the output of the cosine function. After I take the cosine, I'm going to multiply by 2/3, and I'm also going to add 1 to it. What's that going to give me? Well, what's 2/3 times 1? Plus 1 more. 2/3 plus 1. Well, you might say 1 2/3, or you might say 5/3. Is that okay? You're not going to find me doing that here. For this one, I would have whatever 2/3 of the square root of 2 over 2 is plus 1. Because basically what I'm talking about right now is what I talked about last time. What we're doing to the output. These numbers do things to the output. This one multiplies by 2/3, and then at the end I add 1. You could try it here. This might be more interesting. What's 2/3 of 0? Plus 1. 1. What's 2/3 of negative 1? Negative 2/3. Right? Plus 1. So 2/3 of negative 1 plus 1, that one equals positive 1/3. Now let me ask you, in the regular cosine function, what's the lowest we ever get? Well, negative 1. So in my function, y that I'm graphing, you might say, what's the lowest we ever get? Well, the lowest we're ever going to get corresponds to when we have negative 1 with the cosine. And that's going to be 1/3. And I want to show you that. Okay? I can't quite do it yet. There's one more step. The step is, I need to fill in this column of x's. Okay? Now remember, I said that the inputs I'm calling theta. And basically, what do I mean by theta? Well, theta is the stuff in parentheses. Theta equals pi over 2 minus 4x. All right? So if I want to know what are the x values, I have to solve for those. So for example, I'm going to work out what 0 corresponds to. I'll put a 0 in for theta. So 0 equals pi over 2 minus 4x. 4x is pi over 2, I would say that the 0 is corresponding to pi over 8. Pi over 8. And so my x value is going to be pi over 8. And my y value is 5/3. And actually, I want to see that, because I just did a bunch of algebra. It looks like magic. Here, let me go here and hit second trace, which gives me the calculate thing. And I'll hit enter a value. And let me put in, what I just say? Pi over 8. Pi divided by 8. Enter. Well, that's function number 1. That's the cosine of pi over 8. But if I hit the up arrow, that's function number 2. Do you guys recognize that y value? 1.6 repeating. Do you know what that is? 1 and what? 1 and 2/3. 5/3. Okay? This really does give me different points on the graph. I'm trying to figure out what x would give me a certain theta, a certain angle that I take the cosine of. Here, let's do another one. Let's go for pi over 2. So to go for this pi over 2 and figure out what input corresponds, try it, guys. Pi over 2 equals pi over 2 minus 4x. Right? Oh, so when we solve, what do we get x equals? We get x equals 0. Right? So what does that tell me? That tells me that if I input 0 into this thing, then the output should be 1. So let me try that. If I So let's see it. If I hit second calculate again for trace, and I choose a value of 0, it says that my y value is 1. Okay? Now again, why does that happen? That's y1 cosine. Here's y2, 1 and 2/3. I found my problem. Did you guys see what I just pressed? I'm in degree mode. What did I tell you? It's a radian world. I hit my mode button real quick, and I'm seeing degrees. So what's the deal? Why did it do it wrong? Because it thinks I mean pi over 2 degrees, which is like 1 point something degrees, which is really off. Let's put that in radian mode, guys. Make sure you're in radian mode, or else you're going to be just as wrong as I was here. And let's go ahead and try the graph again. Okay, oh, look at that. Well, that looks quite a bit different. Let's hit the zoom and go to Trig. Zoom Trig. Okay, there's my basic cosine function. Here's my wave. And now I'm happy, because now I see that both of these functions go through the value 0, 1. I hit the up arrow, I'm still there. Okay? So it really does work. Let me do one more, and then, or maybe have you do one more. Let's do this, guys. Let's figure out what x value corresponds to pi. Okay? And therefore, what x value will give me an output of 1/3. Could you guys try to solve that for a minute? I'm going to pause and just walk around and see if I've made any sense today at all. I'm trying. So you guys understand that the 2/3 and the 1, those affect the output, right? And that's why whenever I get an output of -1 in the cosine function, I'll have to multiply by 2/3, add 1 to it, and get 1/3. That's like the lowest we're ever going to be on the picture. Because normally, -1 is the lowest we're ever on a cosine. But I'm thinking about input now. And I'm wondering what I should make x equal to if I want to get an input of pi for the cosine function. And so there's an equation to solve. So that's kind of like what I've been doing over here. take your theta that you want and set it equal to what's in the parentheses. See? Because the parentheses is whatever you're taking the cosine of. It's theta. So can you tell me the equation I should write down? What do we want theta to be for this problem? Pi, because I said we're going to go for pi. So let's write down pi equals pi over 2 minus 4x. Okay, tell me what to do next. Solve for x. Subtract pi over 2 from both sides. I know that I'll get pi over 2 left. Right? If I subtract half of pi from a pi, I still have half of pi left. All right, what's the last step? And I get x is equal to, isn't it negative pi over 8? So that's what I would put here. And that corresponds to what output? Yes. And so what is going to be a point on my new graph? Negative pi over 8, comma, 1/3. Let's see that. Here, let me go to the graphs again. Maybe this is confusing because there's two graphs, right? So let me do this. I'm going to go to the y equals screen, and I'm going to just unhighlight the cosine, so I'm only graphing the new one. So this is the function that I'm trying to graph. You guys with me? Now what I'm going to say is that if the x value is negative pi over 8 from my chart, what do I think the y value is going to be? Yeah, so let me put, let me do this. After I have the graph, let's hit second calculate, so it'll figure it out for me. A value, I hit enter, negative, and then second caret gives me pi divided by 8, enter. There it is. Do you notice that's the lowest possible point on the graph? You guys see that? Okay. So if I want to sketch a picture of this function, I think I can do it now. Because I see that the lowest the points ever get are down to 1/3. So for example, at here we have negative 1/8, comma, positive 1/3. That's a point on the graph. What's the highest the points ever get? 5/3. For example, at 0, they're up at 5/3. Okay. Oh no, that's not true. At 0, the output was, or y is 1. So let me plot that point. At 0, I'll put that here, 0 comma 1 is a point. And then what x do I need to get 5/3? I did that before. To get a y of 5/3, that's the highest it's ever going to get, I need to put in pi over 8. You see that? So the picture is something like this. And then the pattern repeats. It starts coming back down to 0, and then it ends up over here. So we had negative pi over 8 gives me 1/3. 0 gives me 1. Pi over 8 gives me 5/3. That picture up there is kind of showing you what's happening. Here, eventually it's going to come back down to the minimum value and then go back up, and it's this wave. It keeps repeating. But the book says graph one fundamental cycle. Let me ask you this. When do we think it's going to get to its lowest point again? What will the coordinates be? Well, I'll give you a hint. I bet you know the y-coordinate. What's the y-coordinate going to be when it comes back down? 1/3. And now the question is, what's the x-coordinate going to be? You had an idea? Go ahead. because you know that the period of the regular trig function is 2 pi, right? Let's look on the picture here. I look at the graph, and if I start, say, moving to the right, I could hit trace, for instance. If I start moving to the right, there I'm at the high point. Now I'm coming back down. It looks like it's down to 1/3 again, but it's at about 1.17. Wonder what that is. It's not 2 pi, is it? Because pi is how much? 3.14. This is less than that, right? But what you notice is, how far was it that I went from negative pi over 8 to positive pi over 8? How many pi over 8s did I go? Well, I went 1 to get to 0, and then I went another 1 to get to pi over 8, right? You might think, oh, maybe he's going to go another couple pi over 8s. How many pi over 8s would it be then to get to here? Here's 1 pi over 8. 2 pi over 8s would put me back down to here. That's pi over 4, comma 1. And then another pi over 8, this is going to be 3 pi over 8. 3 pi over 8. Now, some of you are at your breaking point. I see it. You say, I can't count like that yet. Let me see if I can help. Okay? By the way, just to check, if I hit second calculate a value, and let me type in 3 pi divided by 8, graph. No, I hit enter. 3 pi divided by 8. Enter. There it is, 1/3. Okay? Now, if you guys have your books, page 111 can be extremely helpful. So I'm going to go there now. Here's a picture on page 795, I guess, in the hard copy. And there's a theorem here that tells you how to graph what they call sinusoids. They're basically sines and cosines. Okay? And it says, okay, if you want to know the period, or if you want to know different things about the function, here's some formulas that can help. Okay? Now, notice what it says the period is. It says that if you have the function a cosine of omega x plus, that's phi, those are Greek letters for the angles, omega x plus phi plus b, it says that the period is 2 pi divided by omega. All right? I want to see if I can use that formula here. I'll go back to my paper. And let me say a few things about this function. Okay? So, looking up at the top, here's the original function, number 10. Okay? I already talked about amplitude with you guys. But if I said to you guys, what is the period? Well, the period normally is 2 pi. But I need to divide by omega. But wait a minute, what's omega in the formula? Omega is the number in front of what? In front of x. You guys see that? So we have to be careful about how the problem's written. Matter of fact, some of you guys would take this problem, and if you want to make it look like the formula, you could write it as 2/3 cosine, maybe negative omega plus pi over 2. Negative 4x plus pi over 2. What am I trying to say? What's omega? Yeah, it's that 4, right? It's the number in front, the negative 4. So the period's going to be 2 pi divided by 4, which is what? Pi over 2. That's the period. You don't need to worry about the negative when you're finding the period. The period's some positive number, okay? So when I say the period is pi over 2, that's how long it has to go before it starts repeating. So for example, when I was at negative pi over 8 down here, and I said, well, what's this other number going to be? You could write negative pi over 8 plus pi over 2. Oh, wait a minute. Can't add those. What do I need to do? Okay. So it's negative pi over 8 plus, you change pi over 2 to eighths. How many eighths is it? 4 pi over 8, and you get, which is exactly what I said you would get. There it is. There it is. 3 pi over 8. It's a long time to spend on one problem. I understand that. But I wanted to do one of the more complicated ones to hopefully make some of the easier ones go more quickly. All right? Let's move ahead and try a couple others from the homework. And I want to use this theorem here, okay, on page 111. I think that's going to be helpful as well. So, here's the exercises. Let's take an easier one. Let's try, how about we try number 4? So 4 says y equals the cosine of x minus pi over 2. Okay? I want to go ahead and sketch a graph of that. And actually, if I take out my graphing calculator again, right, I could do the same trick. I could say, well, let me go to the y equals screen. There's y equals cosine of x. Let me just type in cosine of x minus pi over 2. Okay. And I want to graph both of them together again so you can see the difference. Now, here's the basic cosine function. And now I'm starting to graph, what am I starting to graph now? Cosine of x minus pi over 2. Do you notice it's very similar to the one before? What's the only difference? It's a horizontal shift. Just like when you add 1 to the outside, that's a vertical shift. If you add something to the inside, or subtract something actually, that's a horizontal shift. Okay? I mean, we could play the same game I just played. The book does this. They say, hey guys, here's theta, here's the cosine of theta. I know if I have an input of 0, the output's 1. If I input pi over 2, the output's 0. If I input pi, the output's negative 1, etc. Right? But we'd say, wait a minute. That's not what gives me an output of 1 this time. See, because what I want is to figure out what x is. And remember that my theta in this problem is x minus pi over 2. Right? In other words, if I give you some value like 0 for theta, what x value works? Pi over 2. Can I see that? So for the new function, if I input pi over 2, what's the output? 1. Does that make sense? Not yet. Let me see if I can explain it differently. If I do this, guys, if I say, I'm trying to graph y equals the cosine of x minus pi over 2. I know what cosine of x looks like, right? So I know how to graph cosine of theta. Well, because the theta is x minus pi over 2, you could say that the x's are theta plus pi over 2. So the x's that go along with these y values are, what's pi over 2 plus another pi over 2? It'd be pi. What's pi plus another pi over 2? 3 pi over 2. And what you're going to notice is that this is, as you said, a horizontal shift. Which way, right or left? I think it's to the right, which is interesting because it says minus, but it's going to be a horizontal shift to the right by how much? Pi over 2. And when we do that with a wave, it's often called a phase shift. Now, what's the deal? If you look at page 111 again, let me go back to it. We have that little theorem that tells me about all this stuff right here. It tells me that I can get a phase shift by looking at negative phi over omega. In our problem, what is phi? Yeah, well, it's funny because the formula says plus phi, and that's why the formula here says negative. So the phase shift for us would be pi over 2. Because what's omega in our problem? 1. Again, why is that? Because omega is the number in front of what? The x. That's omega. So my omega is 1, okay? So I could say that the phase shift is negative phi divided by omega. Well, that's negative pi over 2, if you want, and so it's pi over 2. And so if you want to know what this graph is going to look like, it's the same as cosine, it's just shifted to the right by pi over 2. And we could see that evidenced on the calculator. Okay? There's the cosine. This one's the same, but just shifted by pi over 2. Again, that's an easier one because omega is 1. By the way, what's the period of this function for number 4? Yeah, it's still 2 pi. The formula they give me is 2 pi over omega. But omega is 1, so it's going to be 2 pi. And you can see that. It's exactly the same. Okay. So this is the kind of stuff we're trying to do when we do the graph. You know, the problem says let's sketch a graph, right? So I would basically take my regular cosine graph and move to the right by pi over 2. And so it's going to mirror it to the right by pi over 2. Okay. But let me ask a couple things. We have the period as 2 pi. We have the phase shift as pi over 2. The only other things I talk about are the amplitude. What would be the amplitude for this problem? 1. Yeah, it's 1. Because amplitude is always given by the number in front of the sine or the cosine. And then is there a vertical shift? No. Because there's nothing added to the back. I'd say none or 0. Okay? Let me try one more. Again, let's do one of the harder ones. Let's try number 12. And then I think we'll move on. What I would like to do again is I'd like to sketch a graph. But maybe first I'll try writing down the period, phase shift, amplitude, and vertical shift. And maybe then I'll try and use those to come up with what my graph is going to look like. So let's see, number 12. Back to my page. And why don't I pause and let you guys work on those things a little bit, and we'll see how it goes. Okay, guys. You guys are doing a nice job. Circle with a line through it, by the way, has a name. Circle with a line through it's going to be called phi. phi, all right, or phi. But now you got a name for it, okay? So we're gonna try and help you through these things here. By the way, I took out the graphing calculator. I'm going to encourage you to continue to use this as you're learning what these different things mean. I typed in sine of x, which is different than cosine, remember. Is the sine function an even function or an odd function? Remember we went over that? What does that even mean? It's an odd function, which means, for example, it's symmetric with respect to... Holy mackerel, look at that thing. That is awful. Let's graph it over. Oh my gosh. Let me hit zoom something else. Let me hit zoom. Boy, that's going to be quite a graph to sketch, huh? Let me hit zoom trig, choice 7. Now, I'm going to pause it. This is the basic sine function, and you told me it's even or odd? Odd. F of negative x is the same as negative f of x, okay? And that may come into play here in a little bit. But we're writing down the function y equals 4 sine of negative 2 pi x plus pi. By the way, do you think that you know the amplitude of this function? What's the amplitude? 4, right? It's always the number in front. Is there any vertical shift for this function? No. I took care of the output right away. So I agree with you guys. The amplitude is 4. The vertical shift, there is none. Okay? And that's why you'll notice when I start to sketch the graph of the function, it's going to be 4 times as high and 4 times as low. It's going to go all the way up to 4 and all the way down to negative 4. So let me do that. I'll finish the graph of sine, start to graph this, and I'm going to pause it again. You can see it goes a lot higher, right? Okay? And you'll notice it's still centered at 0. We didn't shift up or down. Do you guys think we've changed the period? Yes. What's the period of the new function? Well, it's always 2 pi over omega, right? And so it's 2 pi over... Now, what's omega for our problem? Yeah. Although I said don't worry about the negative, didn't I? Right? So 2 pi, so it's 1. Okay? And of course, pi is when we say 2 pi is the normal period, that's like 6. So that's why there's going to be almost 6 times as many of these oscillations as there are for just 1. You can see about 6 oscillations going on. So then the last question is there a phase shift? And the answer is yes. There's a phase shift of how much? Well, what we're supposed to do, right, is we're supposed to take phi and divide by omega. Now, phi here, I have, well, do I have a pi here? And I divide by 2 pi, and so I get 1/2. But the thing I've been ignoring so far is the sign. Plus or minus, right? So is it to the right or to the left? And you're saying to the left, Anna? How do you know? You could see it shifted to the left a little bit. Let's see. Well, I have a tough time telling from the graph, you know? I think one thing that could help here would be to factor out the negative. And so I think I should show that next. If I were to take that negative out front of the 2 pi x, does that make sense to you that what I just wrote down is the same as what's in black? I mean, from your algebra, you factored out -1 plenty of times. And now, I guess what's true is that the sine of negative theta is equal to negative sine of theta because sine is an odd function. Right? And I guess what I'm saying is that another way to write this same problem would be to write y equals negative 4 sine of 2 pi x minus pi. Okay? Now, looking at this, do you guys think that this function is shifted to the right or shifted to the left? Well, if it says minus pi in there, that's a shift to the right. Okay? It's a shift to the right. But then this negative here is a flip. What do I mean by that? Let's see if I can help you understand. Go back to the calculator here. And, for example, I'm going to turn this one off. I just want to graph y equals negative sine of x. Because my question is, do you guys know what's going to happen when I graph negative sine of x? Here, I'll start to graph it. When I start to graph the next one, do you guys know what it's going to look like? Talk to your partner about that for about 20 seconds. See what they think. Let's see if you're right. How many thought that would happen? Sure. And if I do this, if instead of doing negative sine of x, what I'm telling you is that sine of negative x is the same thing. There's some, see? Because sine's an odd function. So I guess when I say that this negative is a flip, that's why I said that. Okay? So really you have a shift to the right and a flip. And if I go back to the y equals screen and if I say, okay, I'm ready to start graphing this thing, and if I clear this one out, I think you're going to agree that we do have a flip. Here's the original sine function, but you'll notice that this one, if you shift to the right and then flip them, what should be on the bottom was now on the top. Maybe it's too hard to tell with that many. I don't know. But anyways, if nothing else, I think this has been a nice example. I guess your question was, should I always factor out the negative? Let me go back to problem 10 and not do the whole thing over. But remember, some people said they would probably write it this way. Y equals 2/3 cosine of negative 4x plus 2 plus 1, right? Some of you thought, hey, let's write it this way so it looks exactly like what's in the book. Well, I guess what I'm telling you is that because cosine's even, you could also write it as 2/3 cosine of 4x minus 2 plus 1. You'd get exactly the same answer because the cosine of negative theta is the same as the cosine of theta. This green one would give you exactly the same graph as the red or the black. Okay? So you have to play with it a little bit to see how that works. Now, so I'm going to go ahead and try and do the secant problem, number 16 here. The secant of x minus pi over 2. I'm going to go ahead and try and graph that. By the way, what does that mean? Secant is the same as 1 over the cosine. It's the reciprocal of the cosine of x minus pi over 2. And I guess what I'm going to tell you is if you want to understand how the secant function works, you better understand how the cosine works. So let me start out by graphing in red here. Y equals cosine of x. Give me some points that are on that graph. 0, comma 1. Thanks. The cosine of 0 is 1. The cosine of pi over 2 is 0. What's the cosine of pi, everybody? Negative 1. That's all from the unit circle, right? Then I get to an important point here. let me just graph one of these fundamental what would this point be here? This one would be 3 pi over 2 comma 0. And then finally here, what's this? 2 pi comma 1. How many are with me on this so far? Right? That's cosine. Well, I guess what you need to know is, what's the deal with secant? Here, let me graph y equals secant of x. And see, now there's some really weird things that happen. Because that's always 1 over the cosine of x. You could think of it as 1 over the red output, because the red output was my cosine function. Let me zoom in a little. That's hard to see what I was writing. So for example, what's the reciprocal of 1? 1. The secant function is also going to have a point at 0, 1. Maybe I should go over one more of these. I know this point. I know that the cosine of pi over 3 is 1/2. Do you guys remember that from our unit circle? The cosine of pi over 3 is 1/2. You guys with me? What do you think the secant of pi over 3 is going to be? 2. Because it's the reciprocal of 1/2. Who follows the idea here? The secant function is always the reciprocal of the cosine function. Does that make sense? I know I'm just dealing with secant x right now. I'll do this problem in a minute. Of course, we're going to have a real problem here. The cosine of pi over 2 is 0, which means you can't do the secant of pi over 2. I mean, you go ahead and try that in your calculator. Kind of an interesting exercise. How would I graph the secant function? I could graph the cosine of x. If I wanted to graph the secant of x, I'd have to do 1 divided by cosine of x. Graph. There's the cosine function I graphed in red. Now what are those big ugly lines? Those are called asymptotes. So for the secant function has asymptotes whenever cosine equals 0. And that's why we're going to have asymptotes at pi over 2 and 3 pi over 2 for the basic function. Now, I need to finish the problem. What I was originally trying to graph is the secant of x minus pi over 2. Talk to me about what's different. Really only one thing, right? What does this pi over 2 represent? Well, it's called a phase shift. Which way? To the right by pi over 2. So what that's going to do, it's going to move everything to the right by pi over 2. What I like to do is start off with the asymptotes. What were the old asymptotes? Well, from the picture, it looks like if I just graph the secant function, I'm going to have asymptotes at things like pi over 2 or x equals 3 pi over 2. Okay? But for this problem, when I want to graph, let me write it again here, y equals the secant of x minus pi over 2. I say, where are the asymptotes going to be? They're shifted to the right. I'm going to have an asymptote, for example, at x equals pi. This one shifted to the right is going to be an asymptote at x equals what? 2 pi? By the way, what's this one? There's another asymptote at x equals 0, because again, it was shifted from pi over 2. So what a lot of people, I think, would do to do this problem is this. Graph the cosine of x minus pi over 2. Graph the cosine function first. So take the cosine function I had above, shift it to the right by pi over 2. And now, we're at, sorry about that, that was a little sloppy. But everywhere that there's a 0 for the cosine function, something like there and there, you're going to have asymptotes. Okay? Or I guess you could graph the secant function and shift the asymptotes by pi over 2. But I'm out of time, guys, so we're going to have to stop for today.